You're lying on your back in a field. No city lights nearby, sky completely clear. You look up and something shifts. Not curiosity, fear. The kind that doesn't have an obvious source. Your chest tightens. Your breathing goes shallow. Nothing is wrong. Nothing out there can reach you. And yet the further your eyes push into that darkness, the worse the feeling gets. That's not imagination. That's something ancient, wired into the same structures that told your ancestors when to run. And here's the thing. Learning more doesn't fix it. It compounds it. Because every time science has reached further into the cosmos has handed something back that feels like a warning. Something that says this far, no further. And we keep going anyway. Start with the numbers. Because the numbers are the problem. The moon is 239,000 miles away. Apollo astronauts got there in 3 days. That felt manageable. Mars at its closest sits 34 million miles out. A one-way trip takes 7 months minimum, not 3 days. 7 months in a pressurized box smaller than a studio apartment. But Mars is still the neighborhood. The nearest star system, beyond our sun, Alpha Centauri, is 4.37 light-years away. At the speed of Voyager 1, the fastest spacecraft ever launched, that journey takes 73,000 years. The Milky Way itself stretches 100,000 light-years across. And beyond it sit 2 trillion galaxies, 2 trillion, each one containing hundreds of billions of stars. The distances don't scale to anything the human brain evolved to process. And the brain knows it. NASA has documented this extensively. The further from Earth an astronaut travels, the more the psychology shifts. In low Earth orbit, 250 miles up, astronauts report something called the overview effect. They look down and feel overwhelming connection. Borders disappear. Conflicts seem trivial. Earth looks fragile and precious from there. That response is at 250 miles. But push further. Apollo astronauts traveling to the moon described something different on the far side. The moment the moon blocked Earth from view completely. No radio contact. No visible home. Just silence and black. Several reported a specific dread. Not fear of dying. Fear of existing somewhere that did not account for them at all. There's a hard physics problem that makes this worse. Radio signals travel at the speed of light. From the International Space Station, a message reaches Earth in under 2 seconds. Barely noticeable. From Mars, at average distance, a signal takes between 3 and 22 minutes one way. If something goes wrong on a Mars mission, you can't call home for help. By the time the message arrives and a reply comes back, whatever emergency triggered it is already resolved. Or not. From the outer solar system, where Voyager 1 currently drifts, a signal takes over 22 hours one way. You are genuinely alone out there. Not metaphorically. Literally beyond reach. And that aloneness has a measurable cost. NASA's own research on long-duration spaceflight identifies what they call third-quarter phenomenon. It's documented and consistent. In any isolated mission lasting months, crew psychology hits a wall about 3/4 through. Motivation drops sharply, irritability spikes, cognitive function degrades. This pattern appears in Antarctic winter over crews. It appears in submarine deployments. It appears in simulated Mars missions run entirely on Earth. HASES, the Hawaii Space Exploration analog, ran crews in isolated habitats for up to a year. Conflict, withdrawal, emotional deterioration, all of it predictable, all of it worsening the further the simulation pushed from civilization. And those crews could look out a window and see a green mountain. Real deep space offers nothing like that. Space itself is not dramatic. That's the part no one prepares you for. No wind, no sound, no smell. The stars don't twinkle out there. They're fixed points. Cold and motionless against absolute black. No horizon, no up or down, nothing to orient to. The human brain requires environmental variation to stay calibrated. Novelty keeps cognition sharp. Familiarity provides comfort. Deep space offers neither. Same view in every direction for years. Same recycled air, same hum of machinery, same faces. Psychiatrists studying Antarctic isolation found that after several months, crew members began reporting what they called the long eye, a 1,000-yard stare. Dissociation. The mind beginning to drift from the present because the present held nothing to anchor to. Deep space accelerates every part of that process by orders of magnitude. But the weight isn't just isolation, it's scale. In 1990, Voyager 1 photographed Earth from 3.7 billion miles away. 1 pixel. Less than a pixel. A pale blue dot suspended in a band of sunlight. Every human being who ever lived. Every war, every empire, every discovery. 1 pixel. That image produced something in the scientists who first saw it. Not only wonder, something heavier. Because the real question the cosmos keeps raising isn't whether life exists elsewhere. It's whether significance itself survives at these distances. At that scale, the concept starts to dissolve. And then there's the silence. The actual silence. The universe is 13.8 billion years old. It contains 2 trillion galaxies. Statistically, conditions for life should have emerged billions of years ago in thousands of separate locations. We've been scanning the skies for radio signals since 1960. Project Ozma was first. SETI followed. 60-plus years of systematic listening. Nothing confirmed. Not a signal. Not a structured transmission. Not a single artifact not made by us. For a universe that old, that vast, that full of potential origin points, the silence isn't reassuring. It is the loudest possible response to a question we're still afraid to fully ask. Scientists call it the Fermi Paradox. Enrico Fermi stated it simply in 1950. Where is everybody? The universe is old enough, large enough, hospitable in enough places. Something should have made contact by now. The most unsettling resolution, the one cosmologists take seriously, is called the Great Filter. The idea that somewhere in the sequence from chemistry to civilization, there is a barrier, a threshold so difficult that almost nothing passes through. If the Great Filter is behind us, we're rare but safe. If it's ahead, then every civilization that reached our current level eventually encountered it and didn't survive. The silence of the cosmos may not be emptiness, it might be evidence. The Chinese physicist Liu Cixin described the logic this way. Imagine a dark forest. Every hunter moves without sound. Every fire is a target. Under this model, intelligent civilizations don't broadcast their presence. They hide. Because contact itself is the threat. Any civilization advanced enough to receive your signal is advanced enough to reach you. And intent cannot be verified across interstellar distances. No framework exists for that kind of trust. The rational move under this logic is silence. Stay hidden. Stay dark. Every signal we've ever transmitted, every television broadcast leaking into space for 80 years, every deliberate message, like the Arecibo transmission in 1974, becomes a mistake. We've been shouting into a dark forest for a century, and something may have already heard us. Here's what drives the fear deeper, the further out you go. Distance doesn't just create physical problems. It amplifies every psychological and existential one. Near Earth, the planet is still visible, still a reference point, still real. Push past the moon and it shrinks. Past Mars and it becomes a point of light. Past the asteroid belt, past Jupiter, past Neptune's orbit, and it disappears entirely. You're not just far from home. You're in a place where home no longer exists as a navigational concept. The evolutionary circuitry that generates fear was built for grasslands and forests, for calculating distance between you and a predator, for knowing which direction to run. None of it maps to this environment. Nothing to run from, nothing to run toward, just void in every direction, patient and indifferent to the distinction. And yet we keep building the ships, keep extending the missions, keep pointing the instruments further out. The James Webb Space Telescope now captures light from galaxies that formed 300 million years after the Big Bang. Images showing the universe as it existed 13.5 billion years ago. Every image is a reminder. We are not at the center of any of this. We are at the edge of one minor arm of one average galaxy out of 2 trillion. The fear that grows with distance isn't irrational. It's proportional. It scales perfectly with what the cosmos actually is. A place with no center, no boundary, no record of our presence, and no particular reason to make room for what we